Good morning, everyone. Myself, Abhidhi. I'm going to present transport phenomena project, which is Fick's first law. Here we go to the PPT slide. Fick's first law of diffusion. Introduction. Diffusion is a process where molecules move from region of higher concentration to the lower concentration automatically. No external force is required. Occurs due to random molecular motion, also known as molecular transfer. uh, Molecular mass transfer. In mass transfer, what happens from the higher concentration, the molecules move towards the lower concentration automatically due to the diffusion. Because diffusion takes place. Diffusion takes place in solids, liquids, and gases. This is a normal diffusion. So, what is diffusion? Movement of molecules to the balanced concentration difference to make the diffusion part equilibrium in equilibrium the diffusion takes place so that we can take any example like here we have three examples like perfume spreading in a room like if we spray some perfume at one corner we'll smell that same perfume at the other corner because the diffusion takes place in the room or anywhere. Like if we light incense stick, which is agarbatti, and we place it one corner of the room or in the puja mandir, we can smell that smell of the agarbatti at different places because the diffusion takes place. Here in liquids, we have example of dissolving in water, in in water. So if we take water and we keep it like that we can see that diffusion takes place very slow because the density of ink is small and the density of water is compared to low. So if we stay or if we wait for some time, the diffusion takes place. In diffusion of liquids, we can take same ink and in cold water and some in hot water. The diffusion in hot water takes place faster because the molecular movement is faster because of the hot vapor present in water and hotness. At the same time, in cold water, the density is higher compared in both liquid and so the diffusion takes place very slow. And in, we have another example of oxygen entering the blood. We breathe through normally lungs, and the oxygen goes to the lungs, and oxygen from there it enters our heart and it diffuses into the blood. Visualizing diffusion. Imagine a drop of dye in water. Initially, its concentration is in one spot. See, same the dye in the sense we have liquid, liquid in. So here diffusion. It concentration as we add, the concentration is higher, and then slower. Some after some time, the particle moves towards the low concentration, and the particle diffuses to equilibrium, and the particle gets distributed equally at the medium. It takes over time. The molecules spread out into the clean water until the color is uniform throughout the container. Here the driving force is concentration difference, which is concentration gradient. In the next slide, fix first law, the definition. Mass flux is directly proportional to the concentration gradient. This is the fundamental law of governing diffusion. In any diffusion, we find the same law. This is a relationship how fast the mass transfer occurs in any medium. This is the Fick's first law. And here we have mathematical equation, which is Ja equals to minus DAB dCA by dy. Uh, we know that Ja is mass flux and DAB is diffusion coefficient. dCA by dy is concentration gradient, and here is the SI unit mole per meter square per second. Here DAB diffusion coefficient is meter square per second, and dCA by dy is concentration gradient, which is mole per meter cube into by, by meter. Let's get back here. Here we use minus sign because minus sign. See, in this slide, significance of negative sign. Why it is negative? Mass moves from higher concentration to lower concentration. Mathematically, the gradient slope is negative in the direction of flow. The negative sign cancels out and makes the flux positive. So we have used it that. And we go next to the again. Let's see. I have explained it clearly. And next, mass flux J. The definition of mass flux: mole by area into time. Number of moles of the particle by area into time. We get the flux. Definition: the amount of mass or moles transfer per unit area per unit of time is known as flux. Key concept: higher flux means the faster the transfer rate. We got the next slide. Diffusion coefficient DAB, which is the diffusion of AB. This represents how easily molecules can move through a medium. High diffusivity molecules, example like gases. Normally, we know that gases have higher diffusivity rate, so that they can diffuse faster. And low diffusivity rate is for solids, in which the diffusivity takes place very slow. The unit is meter square per second, and diffusivity in different phases. The phase of the materials impact the speed. Here, phase of gas, typical value meter per second is 10 to the power of minus 5. The speed is fastest because gases diffuse very fast compared to liquid and solids. Here in liquids, 10 to the power of minus 9, which is moderate, which is considered to be moderate. As I have told that if we drop ink or a dye in or time cold water, we can see that due to the temperature difference, the diffusion takes place like versa, but it is considered to be moderate. In solids, if we come into the solids, 10 to the power of minus 10 to the 10 to the power of minus 14, which is very slow in mass transfer diffusion. The differences. See, here in this PPT, we are explaining molecules are far apart, easy to move in gases. As you can see here, in gases, the particles are arranged little bit far compared to the liquids, which have free space to float. Particles are free floating with no distinct arrangement. Particles move and collide with each other. Here is the space and the particle move freely around the path. Here in liquids, we have the closure uh, molecules compact together compared to gases, and particles are close together with no distinct arrangement. Particles can move and slide around each other. As we can know that particles in water are little bit closer compared to the gases, and they can easily move from other one place to other. We know that. And in solids, we can see that the particles are closely bound and closely packed in a particles. Particles are packed tightly together in a fixed arrangement. Particles can vibrate but not move. In this solid, particle vibrate so that diffusion takes place, but uh, they cannot move freely as compared to liquids gases. Gases molecules are far apart, easy to move. Liquids molecules are closer, more collision takes place. Solids molecules are packed tight, very hard to move, but vibrate easily. Diffusion takes place through vibration. Concentration gradient dc by dy. It is a driving force. It represents the change of concentration with distance. Steep gradient means larger difference in concentration and the result is faster diffusion. Gentle gradient means slightly small difference in concentration, result is slow in diffusion. Next, significance of negative sign, as I have told earlier, J equals to minus D dcy by dy. Here it is negative. Mass moves from higher concentration to lower concentration. Mathematically, the gradient slope is negative in direction of the flow. The negative signs cancels out and we get the flux is positive. Real life examples like perfume, if we spray in at some point of the room and we can smell it throughout the room because of the diffusion takes place in it and we can smell it clearly. Importance and as we have told that lungs in our lungs oxygen diffuses from the air in lungs higher concentration into the blood which is low concentration naturally. Importance in engineering. Fick's first law is a foundation for designing major equipment, distillation columns, separate chemicals, gas absorption, transport of removing pollutants from air, drying, removing moisture from the solids. Visualizing the process. Higher concentration, the diffusion takes place at the lower concentration, and the driving force is uh, the concentration difference. Conclusion. In in this we have seen that how the fixed first law is there and where we use this in liquids, gases, etc. And here it is the total what presentation. Mass flux is directly proportional to the concentration gradient, and diffusivity is transport property controlling diffusion. Thank you for and this is my presentation. Thank you.